every equation I write in the system, I put the name, and the name is 1, 2, 3, 4, 5, so a number. This indicates the equation 1. And we have equation 2, x minus y equal 4. Equation 2. And this represents a system. I am closing the big curly bracket to indicate that this is a mathematical object, no? And you need to solve it out. Okay, this is a problem in 2 dimensions. 2D, because we have 2 variables, x and y, no? X and y. But I promise in a few minutes we study 3D. And 3D includes x, y, and z. Pero no. So far 2D. Entonces this is super easy. I suppose que you know very well this, because this is the intermediate algebra. We have 2 methods for solving the system of linear equation. One method is substitution, another method is elimination. I want to explain both. In this case, it's easy by substitution because I can see that in the second equation, the coefficient is 1 or negative 1. Look, when this situation happens, when the coefficient is 1 or negative 1, the best way is using substitution. So the procedure I want to explain is substitution. And substitution is good. 1 or negative 1. In this case, I have both. So at least 1 is enough. Then you take the equation 2, okay, in my opinion, is the easier equation. And you solve for y or solve for x. In my paper, I copy again. I solve for x. So x is equal 4 plus y. Now you take this expression and substitution in another equation. This is important detail. And the x place, like that. Boom. Okay, so now we have no x anymore. You have 4 plus y plus 2y equals 7. At that moment, we have a new equation that contains only 1 variable. So it's super easy. We combine like term, 4 plus 3y is equal to 7. 3y is equal to 7 minus 4, que es 3, divided by 3, is obvious que y is 1. Okay, y is 1. Now, but I need to find 2, because of the order pair, the solution is the order pair. Now, you plug in either equation, doesn't matter the equation that you select. However, in my opinion, the easy way is plugging in here, because y, x is isolated here waiting for me. So x is equal to 4 plus 1 is 5. Now the solution is the order pair 5, 1. Remember the order is x is the first component, y is the second one. Now, see, I want to interpretation this idea. Look, I have here a slide of the PowerPoint. Okay, but one by one. Let's do it one by one. For example, this is the interpretation of this example in decimals. Now I put in decimals. I create the PowerPoint. The equation is the same. Look, this equation is this equation. Each equation represents a line in 2 dimensions. And the intersection, for example, the equation 1 is the blue and the equation 2 is the green. The intersecting point is the solution, que is the point 5, 1. Any question, guys? It's clear?
Yes, it's clear.
Super. So now, let's move on to the second example. Let me erase the bar. And let's move on to the second example. Example to bring me new situation. Look, ax minus 2y equal to equation 1. 4x minus y equal 5, equation 2. This is my new system. I need to solve it. In this case, I can see again, wow, why the coefficient is -1? So I take advantage of this. You take the equation 2, que is 4x minus y equal 5, and you solve for y. Okay, entonces, well, you move y to the right hand side, 5 to the left, I have minus 5 equal y. Something like that. Okay, super. Now that expression, substitution, in another equation, where in the y place, no? Here. Like so. Therefore, we have ax minus 2 times something. Of course, I put a parenthesis because this is binomial, 2 guys. 4x minus 5 equal to. Okay, now distribute the property. Multiplication here. Ax minus 2 times 4 is 8. And negative 2 times negative 5 positive 10 equal to. Entonces something weird happened. This variable is cancelled out. Entonces I tried to do my best. However, the system don't allow me to solve it because the variable disappear, and you get completely false statement. So what is the interpretation is? Well, the interpretation is that this system have no solution. Okay, algebraically, when you try to do your best, but we cannot solve it, and you get in the final answer false statement, is because the system have no solution. Okay, but what is the geometric interpretation? Because I need to understand much better. The geometric interpretation of this is, look, let me show you. Here. Okay, this equation is this equation. Look, they are perfect coincidence. The example. When I do the graph and the decimals, I obtain 2 parallel lines. And parallel line means that this line never meet. This line never cross it. Therefore, we have no common point. And the solution is the common point. So no common point, no solution. Got it? This example 2 is clear or confusing?
Clear.
Super. Okay, let's move on to example 3 que bring me new situation. I want to erase. Okay, example 3 now. Example 3 is, look, 3x minus y equal minus 2. Equation 1. 6x minus 2y equal -4. Equation 2. Okay. In this example, I also take advantage. Okay, in the equation 1, the coefficient c in front of the y is -1. Okay, good. I like that. Therefore, I copy again the equation 1 is solved for y. For example, 3x stay here, plus 2 equal y. And this expression, substitution in another equation, que es equation 2, and the y plate, of course. So my new equation is 6x minus 2 times parenthesis 3x plus 2 is equal to -4. Okay, now distribute the property 6x minus 6x because negative 2 times positive 3 is negative 6, and negative 2 times positive 2 is negative 4 equal negative 4. In that case, again, the variables cancel, so we cannot solve it. However, this is different because you get true statement. Not necessarily in every example you get negative 4 equal negative 4. You get negative one number equal another number, positive or negative or 0. But it's true statement. This is important information. Entonces, what is the interpretation of that? Well, let me try to explain. In this example, we have infinity many solutions. Why? Well, because the equation 1 and equation 2 is the same equation. So we have no, actually at the beginning, you suppose you have two equations. No, you have only one. Therefore, how you prove that? Well, if you, for example, you multiply the equation 1, you multiply, let's use in this symbolic way, multiply by 2 positive. So you multiply the entire equation 1 by 2, you have 6x minus 2y equal negative 4, que es exactly the equation 2. So you prove mathematically that these equations are dependent. And to solve the system, we need a independent, linear independent. What means to be independent? Well, okay, when you multiply by a number, of course, non-zero, positive or negative, and magically you obtain another equation is because they are linear dependent. This linear dependent don't count in the amount of equation that you have in the system. Actually, we have only one. Another way to see that. Suppose I take one more time when actually I did that. Here, the equation 1, I solve for y. Let's do it exactly the same in the equation 2. 6x minus 2y equal negative 4. And you solve for y. Minus 2y is equal minus 6x. I move 6 to the right hand side, and minus 4 stays the same here, right? And divided by negative 2, because my goal is isolate the y. Here we have y is equal, this is 3x plus 2, no? So negative divided by negative positive, negative divided by negative. Wow, and you get exactly the same equation. I prove by the multiplication, or I prove for solve for y or solve for x, is identical equation. Actually, my problem have no two equations, have only one equation. Okay, additional, if you want to see the situation geometrically, because one picture is much better than 1,000 words and 1,000 equation, I bring this slider that contains exactly the same system. When I do the graphic, it's obvious that we expect the same line.
Professor, you're muted.
Okay, you hear me now?
Yes.
Okay. Pero I'm muting for a long time? Or?
No.
Okay. Okay, maybe the problem is that my pen have a button, and maybe you not intentionally press this button to say, okay. Thank you for saying. Okay, the thing I try to explain is this system and the example number 3 have infinity many solution. Okay, infinity many solution is the point on this line. Okay, it's the same line. I proved that. Another point out the line, no solution. Es infinity-many solution, but not all real number. No. It's specifically the order pair on this line. How you write that? How you write that? Let me try. You write that. Solution. Set. It's infinity, I know. It's all order pair x comma y, such that y, for example, obey to this mathematical equation, 3x plus 2, but x is any real number. It's a one possibility, no, to express. No, okay, the traditional is that way. However, normally in mathematics, we suppose that x is an independent variable. That is the reason it's independent, no? It's free variable. And why not? Why somehow depending of x according to this relationship. Okay? So in this moment, I want to stop. Yeah, I want to summarize the thing that we are doing so far. So far, we are doing this idea. Okay, we have three possibilities. For example, this is the analysis in 2D. Summary in 2D. Well, 3D is more complicated. We have three possibilities. Okay. The most common possibility is that you have two equations that represent two completely different lines, and we have solution point here. This is one solution, unique solution. And when this situation happens, the name of the system is called consistent. Okay, the word consistent indicates us. Okay, the system has solution, at least one, and it's independent. Independent means, so one interpretation, independent is that you have completely different graphic. This is a line 1, this is a line 2. Okay? Now another possibility is no solution. No solution. And in no solution, we have two parallel lines. Line 1, line 2. And never meet, never intersection, no solution. And the name of the system is inconsistent. Inconsistent means that we have no solution. It's equivalent, no? It's synonym. And it's independent also because this equation is have a completely different graph. Okay? This is x and this is y. Now remember, independent is when you have different graph. Entonces, the last solution, que es infinity-many solution, infinity-many solutions. Okay, in this case, the system is also consistent because the fact that we have solution means que es consistent. No? If we have only one, perfect. But if you have infinity, I suppose it's much better. No? In that case, the lines are coincident. Okay, this and this is the same. So it's line 1 is equal to line 2. We have infinity-many solution, but the problem is that the system is dependent. Dependent means that we have the same graph. This is the three possibility in 2 dimensions. Okay. one more thing I try to explain in that part. Look, this is important analysis. Okay, this analysis now I extending in multi-dimension. Suppose. You want to analyze. Well, no. Let's explain one more thing, and after immediately I analyze this equation. Okay. So far it's clear, guys? Oh no?
Yes, it's clear.
Okay.
So far.
Okay. So I want to explain another way for solving the system in two dimensions, que es elimination. In my opinion, elimination is the best way. Because not always we have the option que the coefficient is 1 or -1. Bueno, entonces you can use substitution. You can, but it's horrible because you need to manipulate with the fraction. No, not good. Suppose example 4. In example 4, we have two equations again, 3x minus 4y equal 1. This is equation 1. And 2x plus 3y equal 12. Okay, super. Equation 2. So this system is given, I need to solve it. In this case, I see, wow, every coefficient in front the variable is no 1 or -1. Okay, entonces I discard mentally the possibility of the substitution. You can, pero es hard. Entonces, elimination is fantastic. What is the key idea behind elimination? Well, elimination, you need to create artificially, of course, not always is given. Two coefficients, for example, minus 12y and plus 12y. Okay, this is the one equation, and this is the second equation. And when you add in equation 1 plus equation 2, the solve, you get that part cancel. This is the idea behind elimination. So, for example, for create this condition, I propose you, for example, multiplication this equation by 3. Because 3 times 4 is -12. This is a number that I use it because it's the number applied in this example, but not all will happen, no? And multiplication the second equation by positive 4. What is the idea? 3 times 4 is -12, 4 times 3 is positive 12. Ready for elimination. This is the only possibility we have? No, of course no. So you need to think when you face that problem, you planning your own strategy. Another possibility is suppose. Of course, I need to make decision because I cannot solve in the system in every possibility. No. You thinking what is the best strategy for you. In this case, I take advantage que this sign is positive and negative. Entonces it's easy for me. But another possibility I want to discuss it, but I don't want to use it, is suppose que you multiply the first equation by 2 and the second equation by multiplication by -3. Why? Because 2 times 3 is 6 positive and -3 times positive 2 is -6 and ready for elimination the x part. Pero no, I want to use it the first one, que I consider it better. Why I consider it better? Because actually I take the natural sign, que is positive and negative. When you multiply the first equation by 3, we have 9x minus 12y equal 3. And this is my new equation 1, que by the way, is identical to equation 1 original. The only difference is that the number is bigger, but it's the same line, you know? And when you multiply the equation 2 by 4, we have 8. 4 times 2 is 8 plus 12y equal 48. This is equation 2. This is my new system. Now you're adding equation 1 plus equation 2 by column, no? The column of the x is 17. The column for the y, wow, cancel. This was my intention. And this is 51. And finally, divided by 17 both sides. X is equal 3. I'm going to find the y value. Well, you select either equation. In my paper, I select the equation number 1 because I consider it easier. Yeah, a specific reason, but okay. It's 3 times 3 that you replace x for 3 because I know the value minus 4y equal 1. Yeah, it's all for y. 3 times 3 is 9. Negative 4y is equal 1 minus 9. Negative 8 divided by negative 4 both sides. Y2. And the solution is the point 3,2. 3,2. 3,2. So this is the classical example in which you have unique solution because the equations are linear, independent, and also, let me see, I bring the graph here for this example. In this example, look, let me show you. Whoa. Okay, is that system? It's the system we solved before. We have two equations. Number 1 equation and number 2 equation. I suppose the number 1 is the black one, and number 2 is the red one, and the solution is 1 point. Any question? Any question? Okay. Everyone follow me? No problem. It's clear, no? It's
Yes.
clear. Okay, super. That was refresh your memory about solution of the two systems, but I want to extending the interpretation for the multidimension. No? This is the problem. So the multidimension, for example, I have so now a system in 3D. It's a linear system. In 3 dimensions. Okay. For example, example 1 for the 3D. X minus 3y plus 3c equal negative 4. Equation 1. 2x plus 3y minus c equal 15. Equation 2. And 4x minus 3y minus c equal 19. Equation 3. Super. Okay. First of all, let me try to understand the interpretation of that. We have 3 equations. We have 3 unknowns. So the number of variables minus the number of equations represent always the degree of freedom of our system or our mathematical object. For example, to understand this equation, in 2D, we have one equation, x plus y equal 1. Only one. Suppose only one equation. Okay, entonces, two variables we have. Number of variable 2. Number of equation 1, because I take only one equation. And 2 minus 1 is 1. So what means degree of freedom 1? Degree of freedom 1 represent a line, because a line is a geometry object that have only one dimension, no? That the line have length, but no width and no height, one dimension. When you have the system in 2D, x plus y equal 1, I don't know, another equation, 3x plus 5y equal 4. When you take 2, so my problem now is not one equation, you know, two equations. We have two equations minus 2, so two variables, sorry, x and y minus 2 is 0. 0, 0, 0, degree of freedom 0 means it's a point. Or at least if the number of equations are linear independent. Si es linear dependent, Of course, this situation happens in infinity many solution that we discover that you actually, in the problem is given at the beginning, we have two equations, but however, they are linear dependent. So actually, it's no two equations, it's only one linear independent equation. That is the reason that we have infinity many solution and the degree of freedom is a line. Do you understand this? Or look like complicated abstract? Yes or no? Answer me.
Yes, yes.
Okay. Now, so you understand the situation in 2 dimensions. I want to apply this equation in 3 dimensions. Okay. In 3 dimensions, 3D. Suppose that we have only one equation. X minus 3y plus 3z equal -4. Okay. Number of variables on this equation is 3. Number of variables is 3. Number of equation is only 1 because I take the first one. You have 2 degrees of freedom. Degree of freedom means that my object can represent the first equation is a plane. Why plane? Because plane is the geometry figure that has 2 dimensions. No? We have surface here. So we can move in this direction and in this direction, 2 dimensions. However, when you include more equation, more linear independent equation in my mathematical problem, as you have three equations like this problem, no? 3 equations minus 3 variables, sorry. The number of variables is 1, 2, 3, x, y, z. And 3 equations, degree of freedom is 0. Because we have 3 planes in the 3-dimension context. Maybe we have solution. I don't know si es one solution, si es infinity many solution or no solution. It's the same situation, the same typical cases. However, you need to understand this. Okay, so now before I start the algebra of this part, I bring here one slider que illustrate que is more complicated in 3 dimensions the problem. Okay, we have several possibilities. You have several possibilities. So I would like you pay attention, everyone, in this example. Look, in this. And this illustrate 3 planes, yellow, red, and green. And the intersection in this plane is the typical example I will do now is a point. So a point represents the solution. Okay, degree of freedom 0. Pero no always happen that. Suppose suppose this example. In this example, we have solution. Yes or no? What do you think? No solution or or infinity many solution or well, actually unique solution, no. Because to be unique solution, we need the point, degree of freedom. That means that the red, green, and yellow equation, que represent the plane in 3D, have some common point, but not only one, sino infinity many solutions. Do you see? This line is a common line in between three planes. Therefore, I suppose that this system, when I solve it by hand, or because we studied in this chapter, solve it by hand or solve it by computer. Because a sophisticated problem is totally crazy, do it by hand. I want to explain by hand today. When you solve it, you discover in the middle of the process that at least no, two equations are dependent. That is a reason there's no unique solution. Makes sense, right? However, what do you think about this case or that case? Do you believe that we have solution in this case or no? Remember, to be solution, we need common point. But common point in three equations. So is there common point, for example, in this case? Is there common point in between the yellow equation, green equation, and red equation or no? No? Yes? No? Yes? Answer me. I wait for you. So you make a mistake, no problem. You're a student, no? We have a solution or no? Nobody have opinion? Wow.
I think.
Uh-huh.
Well, I'm not sure because
No, it's okay.
the planes are parallel. So, but the line, one of the planes goes through. So maybe there's one solution. I'm not sure.
Okay. Another opinion. She said that it's not sure that you have solution. Remember, we have three possibilities. One solution, infinity many solution, or no solution. Okay, it's the answer I expect to you. Okay, Professor, I see que no, unique solution. But I saw several, infinity many, or no solution. Okay, another opinion, come on. Who are you, miss? You are the sister, no?
Oh, no.
No. What is your name?
Isabella.
Isabella. Okay. Okay, another opinion. Come on, what happened with the male students? Carlos, are you there? Carlos Lopez. No. Don't feel pressure.
Would it be infinite many solutions?
Another opinion. Okay, putting off the microphone. Okay, look. Remember, important thing is que when you have intersection, we have solution. Entonces, I see. Let me show you. Let me make it zoom. It's obvious que in that part, we have common point between the yellow and green. Yes or no? And also, we have a common point here in between green and yellow, correct? But we have no common point in between three planes. So is there a common point between yellow, green, and red plane? No. Therefore, no solution. Do you see clear now?
Yes.
To be solution, we need the common point in between three because we need to satisfy three equations, right? And this is also no solution by the same reason. Okay, so when this information is now a little bit more clear, let me know in that part. Okay, look at that. Here, that one. We have solution or no? Yes or no? Opinion.
Because there's a point.
Yes. You see clear the point, common point, solution. And this, solution or no?
Infinite because of the line.
Exactly, infinity many solution. By the way, let me introduce this new idea. Not new, but a little bit the solution, we have infinity many solution, correct. However, the solution set or the solution object is a line. And the line, when you're talking about, okay, this line is because you have 1 degree of freedom. That means that when you write the final answer, you suppose that we have 1 free variable. So the number of the free variable that you obtain in algebra, okay, I want to explain in detail, represent the dimension of the solution set. See, as a line, we expect, when I finish my problem by hand, I expect 1 free variable. Okay, what do you think about this guy? Get horrible, this guy. What do you think? We have solution or no?
No solution.
No solution. Infinity many solution, no?
No, because they don't intersect.
Exactly. No solution. This is typical no solution. Okay, what about this? What about this? Another participation. Come on, guy.
That one has a solution.
No solution. No?
No,
Oh,
it has
yes.
a solution.
No, no solution, right? No. And what about this? What about this? Solution or no?
Has 1 solution.
One solution. Very good. You get approximately the idea. Entonces, maybe you say, bueno, professor, but I see when the plane are perpendicular. It's when you have solution. No, not necessary, guys. Look at this example. I want to solve it now algebraically. No, this no. Let me see. What is the next? This one. Yeah, this one. This one. In this case, it's exactly the same. The thing I want to solve it now algebraically. Okay, try to find the geometric interpretation. We can use in GeoGebra to do that, but that's not important for us because the graph in 3D is complicated. And the graph of 3D is only applied in calculus 3. So in this level, you don't want to see. Well, you can, but it's no big deal. But when it's a linear, but when there's no linear, it's more complicated. But this system, you can see that we have unique solution. Look, I want to find in few minutes, boom, and not necessarily the plane are perpendicular. Okay? Okay? Okay. Okay. So let's doing. How you solve the system in 3D? Well. You, for example, you planning one strategy similar to the 2D. Let's do it by elimination, of course. Let me see. Say I erase something here. I erase C here, right? C. C. Okay, and the original, I don't know. I delete this C. Okay. So now, what is the procedure? The procedure is you thinking one strategy. Yeah. So wow, look at that. Look at that. Not always happen, but in this case happened. This column, okay, the Y column, have -3 and +3. Oh, entonces ready for elimination. Do you see? Not always happen. I put elementary example to start. After I promise I complicate more. Okay, entonces you pair 2 equations. Entonces in my paper, I select the equation 1. Okay, I always copy the number because I need to guide for the number. And equation 2, because I saw using my eyes que at least y is ready for elimination. Okay, no necessary multiplication. No. Ready. You adding by a column 1 plus 2 equation is 3x. Elimination that part. I take advantage of this. And 3 minus 1 is 2. Equal 11, no? Okay, super. Now this equation I call equation number 4. Okay, this equation contains only 2 variables. Everyone follow me so far? Everyone follow me so far? Okay. Now this is the most important moment. Now I pair another 2 equations, maybe 2 and 3, or maybe 1 and 3. But the most important moment is you make a decision in the first couple of equations, eliminate y, and the other couple you eliminate also y. So you eliminate another variable that you want to see in the example 2. You are in trouble, big trouble. So I copy the equation 2. And equation 3. Because according to my strategy, I want or I need to eliminate exactly the same y. This is important, guys. So you eliminate here y and you eliminate here z, or you eliminate x, no, you never get the answer. Okay? Now, adding by column, so 2 plus 3 is 6x. The y is gone, minus 2z equals 34. And it's equation 5. Okay, so I have at that moment, so you are doing reduction of the equation. So actually, the thing we are doing is you try to find a line, okay, intersecting equation 1 and equation 2. By the way, equation 1 and equation 2 is a plane, and when you intersect in 2 planes, you have a line. So equation 4 and equation 5 is equation of the, well, it's a line. No, not exactly, but okay. Now you take 4 and 5 together. 6x minus 2z equals 34. Okay, it's equation 5. And you form a new system. But this new system is super easy. It's similar to the problem that we solved in 2D. And by the way, it's ready to apply elimination because positive 2z and negative 2z is cancelled. Choom! Fantastic. So you adding this at 9x and this is 45. Divided by 9 both sides. X is 5. Oh, I got it. At least I have in my hand one solution. That means, okay, obviously we have unique solution. No? In order to find the other component, y and z, use substitution 5 in either equation, pero no in the original equation, because the original equation 1, 2, 3 contain 3 variables, and you have only one in your hand. So use substitution in number 4 or number 5 in order to find. This is the order. This is the organization, and you need to respect this organization. For example, in my paper, I select the equation number 4. You can select 4 or 5. It doesn't matter. You select number 4. So you plug in 3 times 5. You replace x for 5 plus 2z equal 11. That's all for z. This is 15 plus 2z equal 11. 2z is equal 11 minus 15, okay, negative 4, divided by 2. So you can see it's negative 2. Super. Now using two variables, entonces I can using either equation, the original equation. Maybe 1, maybe 2, and maybe 3. In my paper, I don't know why, I don't remember very well, I select number 2. The beauty is that you can select either equation. Of course, the answer doesn't change. Entonces es 2x, pero x es 5, ¿no? Plus 3y, okay, I have no idea who is y, minus z, be careful with the sign, because the equation have minus here, and the value for the z is negative 2, so you have double negative, equal 50. Okay. This thing, this is 2 positive, double negative become positive. Combine like term, 3y plus 12 equal 15. 3y is equal 15 minus 12, get 3. Minus 12, get 3. Now divided by 3, y1. Okay, our famous solution point is the triplet order, because we have 3 components. X, comma, y, comma, z. You write in that order, alphabetic order. X is 5, y is 1, and z is negative 2. End the story. I finish. Entonces we expect the point exactly the same. You see geometrically, because the equation 1, 2, and 3 represent 3 planes, and these 3 planes share a common point, que es the point 5, 1, negative. Okay? Super clear? Or super confusing?
Yes, yes, it's clear.
Clear. So you need to practice. You need to practice. I promise, guys, que bueno, this is too long process, no? Chewy. To simplification this, and this is too long in 3D. Suppose 4D, 5 dimension, and so on. It's possible in the real life to have that, because in the engineer problems, you have 20 equation and 20 variable. You solve it. Solving by hand is crazy. It's impossible. So I want to show you how you organize this and put it in the computer. Okay, and we using the software that is available online. Okay, look like interesting this or no? Huh? Look like sound interesting or no?
Yes, yes.
Okay, small example 2 in 3 dimension. Okay, A ver, opinion. Let me see. Dice interesting but need practice. Okay, okay. Entonces, how you get the practice? You get the practice doing the homework. And when you are doing the homework and you are stuck in one problem, you ask me by email or some student. I don't know. I don't remember the name. Send me to yesterday at 9:16 p.m. one question. Entonces, no, and in this moment I am watching TV, no? I am doing one movie in Netflix, no? Entonces I open in the morning. Maybe I answer. So you need to start the homework quickly, okay? Entonces, when you stop, you have possibility to ask me anytime. Si I don't open the email, well, okay. Pero when I open, I just solve it in 5 seconds. I send the solution, no? This is some students take advantage of this possibility. Another possibility is yesterday, so every Wednesday, I am in the tutoring, virtual tutoring. And no student asked me anything. Well, no. Another student for another professor get inside this and ask me. But no, you. So this is the way to study, guys. Okay, example 2 now. Example 2 say negative x plus 6y minus 3z equal negative. Equation 1 que represent in 3-dimension context. 3-dimension is the axis like that. X, Y, and Z. And this equation, I don't know exactly, professor, but I know the only thing I need to know is the plane. Okay? The graphic of the plane and graph in 3D is very, very complicated. This is Cal 3. No pre-calculus or no algebra. Okay, you don't worry for this. Second equation is x minus 2y plus 2c equal 3. This is my second equation. And my third equation is 3x plus 2y plus 4c equal negative 6. Okay, and this is my problem. It's a system that contains 3 equations, 3 or no. Okay, exactly the same strategy. You pair 2 equations. In my paper, I pair 1 and 2. The reason I pair 1 and 2 is because I saw, wow, okay, in the first equation you have negative x, in the second equation you have positive x. Oh, we're ready for elimination. Super. I take advantages. Not always happen, but in this case happen. Okay, I take my first equation, guys. Important this organization, at least for me. X minus 2y plus 2z equal 3. This is my equation. You add in the equation 1 plus equation 2 by column. It's obvious that that part cancel. And we have 4. 4y, 6 minus 2. Minus c, minus 3 plus 2 is negative 1. Is equal to negative 5. Wow, this is my 4th equation. Super. No problem. I understand now. Now, for example, I don't know, I take, so not necessarily you solving in exactly like me. That was the strategy I saw in the moment I do this paper. However, there are another possibility. For example, you take the equation 2 and the equation 3. Okay. X minus 2y plus 2c equal 3. Equation 2. I repeat again. And equation 3 is 3x plus 2y plus 4c equal negative 6. Okay, it's equation 3. As I see, wow. It's ready for elimination of the y. Because negative 2y and positive. But no, this is mistake. Because remember, you eliminate in the first couple of equation x. The mandatory, you need to eliminate the same verb. Okay? This is important detail. I create this example to illustrate very well this idea. No? This is one I like. No, you don't like. You are, so you make one decision, you are continue with the same problem. Entonces, bueno, okay. Entonces, the intention is que you need to eliminate x in the second couple. Okay, no big deal. You multiply the equation number 2 by negative 3. No? Because when you multiply the equation number 2 by negative 3, we have negative 3x plus 6y.
Professor, why can't you cancel 2y? Like, I know you can only do it with the same variable, but why can't you do it with the y?
The reason that you cannot do that is because in the first couple, you eliminate x. In the second couple, I need to respect. I need to eliminate x. No y. Because what is the final condition? The final condition is I have equation 4, that depending only for the y and z. Entonces, I need another equation phi que depende only of the y and z. Entonces, matching perfectly, put together 4 and 5 in order to continue the process. So you eliminate y, que you want, I know, I notice, que you want, because you see -2, no, wrong, because you have 5 equations, okay, when you eliminate y depending of x and z. Entonces you stay in the same way, and you have 2 equations and 3 variables. It's a mess. You understand the idea or no? Yes or no?
Thank you.
Okay. Let's continue. Multiplication by -3, the second equation. We have -6z equal -9. This is my equation 2 again. They are linear depending, so they are not different, but they're ready for elimination. Cancel out the x, gets the same variable of these. Look, and we have ay minus 2z equal -15. And this is my famous equation 5. And you put together 4 and 5. I put ay minus 2z equal -15. Equation 5. And we focus to solving the system case 2. Equation and 2 unknown, similar to the 2D problem. So you are doing reduction of the dimension. You convert the problem from 3 dimension and 2 dimension. Okay, this is the idea. Okay, so now in this case, I guess so. Okay, in order to make elimination process, you multiply, for example, this equation by -2. What is the intention? The intention is -2 times 4 is -8, so it's -ay ready for elimination, at least that part. -2 times c is plus 2c, and -2 times -5 is positive 10. And this is my equation 4. Okay, completely dependent. You add in now 5 and 4, and you see, wow, what the hell is that? Look, everything is cancelled. The variable disappear. So that smell, okay, this is a special, no unique solution. And you have -5. And this statement is completely false. So what means that? I try to do my best. However, I cannot solve it. You get false statement. What is the interpretation of that? Algebraically, when you manipulate, something disappear, the variable. I cannot solve for z, for y, for x. No. However, you get contradiction. It's because what? Interpretation.
There is no solution.
Exactly. There's no solution. Okay, I illustrate this situation in one slider of the PowerPoint. Look at that. I suppose it's this. Yes, it's this. Look. Okay, I put equation in the software to make a 3-dimensional graphic. I saw 3 planes, the red one, the green one, and the blue. And they are no common point in between them. That is the reason that we have no solution. Super clear or super confused? Super clear?
Yes, it's clear.
Okay, let's move on to example 3 in 3D. Example 3 in 3D. Okay, erase. Okay, example 3 in 3D. Okay. Example 3 say, well, 2x plus y equal -3. Equation 1. 2y plus 16z equal negative 10. Equation 2. Negative 7 x minus 3y plus 4c equal 8. Equation 2. As I put intentionally a little bit weird, because sometimes happen in the real life. Okay, the equation, sometimes we have a missing variable. For example, the equation 1, okay, by the way, it's a plain also, no? Z is missing. In the equation 2, X is missing. In the equation 3, no. Everything is present, X, Y, and Z. But you don't worry for this. You manipulate exactly the same. For example, I take in my paper equation 1 and equation 2. Yeah, I copy separately here. 2x plus y equal 3 or minus 3. Yeah, I copy. I copy this equation a little bit motion like that. Put it in the column, no? 2y plus 16c equal negative 10. This is my equation. Okay. Entonces I make a decision. I multiply. Maybe I multiply the equation 1 by negative 2, because my intention was okay, you multiply, you have negative 4x minus 2y, you know, that part ready for elimination. Equal 6 positive, no? And this is my equation number 1 now. And you add in by column 1 and 2, this and this, of course. Negative 4 stay here. This is cancelled. 16 bring down. And in the right hand side, so after the equal sign, we have negative 10 and positive 6 and negative 4. Okay. And this is my equation 4. Okay, one possibility always okay, you have is you see, wow, I don't like that number, right? You can divide by, suppose I perform that operation. You divide this entire equation, divide by, no multiplication, divide by negative 4. It's possible because the number involved in the problem is negative 4 and 16, you know. It doesn't mind when you divide by negative 4, this is not mandatory to do, but this is good. You have x minus 4z equal 1. Okay, this is my new equation 4. Okay, by the way, it's dependent. It's exactly the same equation and the number 4 I declared at the beginning before divided by. Remember, when you multiply or divide, it's the same operation. Because multiply divided by negative 4 is the same multiplied by negative 1 over 4. The new equation is completely dependent of the original. It's the same. It's the same in this case, the same equation. Now I select another couple, suppose 2 and 3. Suppose I copy 2y plus 16z equal minus 10. This is equation 2. I copy, I try to line up using the verb, but this is the reason, guys, que the mathematicians create matrices. Matrices is fantastic. Because matrix is an array of numbers, so you put in line, column, but we see another day, matrices. Okay, now there's a negative 7x minus 3y, I just copy, plus 4c equal positive 8. This is my equation 3. I need to do something. Well, this something is multiply multiply the first equation, suppose by positive 3. I'll multiply the 3 equations of the second equation by 2. What's my intention? My intention is to get 6 and negative 6. Okay, copy that. 6y plus 48z equal minus 30. Okay, this is my equation 2. Identical. Now, multiplication by 2, the number 3 equation is negative 14x minus 6y. Wow, I like that because it cancels out. Plus az, because 2 times 4 equals 16, because 2 times, that's equation 3. Okay, so now, I bring down negative 14x, no y disappear, good, exactly the same intention I did in the first couple. Plus 56z is equal negative 14. So negative 30 plus 16 is negative 14. Okay, super. I like that. However, I can see the coefficient in this equation is possible reduce a little bit because you can divide it by negative 14. So you divide by negative 14, everything. Negative 14, negative 14, and negative 14. Suppose you don't see that. Well, no problem. When you put together the equation, you realize. But in this case, I realize in that moment, no? You have x. You have x, no? It's x minus 4z equal 1. And this is my equation 5. This is my equation number 5. This is x. I got it wrong in my paper. X minus y equal 1. Wow. Something weird happened here. When you put together 4 and 5, you see that they are identical, no? So what is the interpretation of this? What do you expect can happen when you solve this system 4 and 5?
Infinite solutions.
Excellent. When you see identity, true, this is true always. This is infinity many solution. Okay, so how you write that? This is a challenge. Okay. So to do that, okay, I write something. I know get infinity many solution. Infinity many solution. Identification because it's the same equation. Those you have, for example, so you adding this or multiply by negative 1, you get 0 equals 0, no? Or 1 equals 1. Infinity many solution. You know get identity, right? So the solution set is the triplet order because the solution living in the 3-dimensional context, such that. So I need to declare or define one free variable or two free variables depending on the problem. No? In this case, I saw that the connection between, suppose I declare CF free. Free means que C is any real number. That is a reason, no? Que es infinity many solution, no? And the connection between x and z is x is equal 1 plus 4z. So you solving, always happen, you solving the variable that you consider not free as a function of the variable that you consider free. Entonces x is equal 1 plus 4z. Okay, nice. What about y? Well, y do not participate in this game because remember I delete y in the first couple, I delete y in the second couple. Entonces I have no information for the y. But yes, we have, because in the equation number 2, this is a glue. This is the connection. The equation 2, look, S2y plus 16c equal -10. And you can solve y as a function of the c, que c I declare like a free variable. 2y is equal -10 minus 16z divided by 2. And y alone is -5 plus ac. Plus, no, minus. Yeah, both negative. Minus ac. Okay, no, super. We almost finished. Y alone is -5. This is the connection between the non-free variable and c, que es the free variable. -5 minus az. C is a free variable. And what about C? Well, C is any real number. End the story. This is the formal way to write the solution set. This is one possibility. No, another book using another way that I want to present because that's similar. So you know that the solution is triple order, X, Y, and Z. And C is C because it's free. X is 1 plus 4C, and Y is -5 minus AC. And separate by comma, and this is the solution. And the solution is obvious que contain only one free variable, que es C. And this determines the dimension of the object is formed in 3D. It's a line. How do you know it's a line? Because you have one free variable. Entonces it's a line. And line is in 3D one object that contains one dimension. That is the reason that we have one free variable. Make sense? Make sense?
Yes.
Okay, super. Now, well, okay. I want to see the graphic of this by curiosity. The graphic is curiosity, guys. To understand, to see one picture that represents that situation, no? But you don't need to do that. When you take calculus 3, you take calculus 3. Okay, by the way, the only teacher que explain this in Honte Campus is me. I teach in the summer, but you cannot take in the summer because you need to take calculus 1 and calculus 2, no? The student can need to take calculus 3. It's only for the student for the engineer and science. Okay, I copy the equation, and you see, wow, look at that. The equation contains one common line. This is the famous line that we are talking about. Super. Do you understand the idea?
Yes.
Okay. Remember that you understand does mean that you know very well this. You need to practice, okay? Que you understand is the first step to get the idea. One more example in 3D. Example 4, no? Example 3. It's 3, no? 1, 2, 3? Yeah. Let me see how many. One solution, no solution, infinite dimensional solution, 4. It's a 4. It's a 4. Example 4. Okay, no good there. Example 4. Okay, X plus Y plus C equal 10. Equation 1. 2X plus 2Y plus 2C equal 20. Equation 2. negative 5x minus 5y minus 5z equal negative 50. Equation 3. Wow, I saw something weird, and that's it. Do you see something weird? What do you think? What's going on in this system?
Two and three repeat plus.
O sea, she saw que equation 2 is dependent of equation 1, no? Because you multiply by 2, it's the same equation 2, no? And 3 also, because in this case you multiply by negative 5, no? So you multiply the equation 1 by negative 5, you obtain the equation 3. And remember, this concept is important. When you multiply any equation by a number, the new equation is dependent of the original equation. So 1, 2, and 3 represent dependent equation. Therefore, remember the formula. To get the solution object, you have number of variable okay, obviously in this case 3, no? 3 variable x, y, and z. 1, 2, 3 minus number of equation. In this case we have 3 equations, but actually we have only 1 equation independent. Es the adjective. Equation is independent. Okay, we have only 1, no? And 3 minus 1 is 2. So the degree of freedom, this is degree of freedom of the solution object is 2. So what means that? What means that the degree of freedom is 2? What geometric object we expect in this case of the solution? And when the degree of freedom is 1, is line. When the degree of freedom is 0, is a point. When the degree of freedom is 2, what is the object? What is the object? Que the dimension is 2.
A plane.
It's a plane. Very well. It's a plane. So by the way, you discover, it's not new, okay, we have a plane, right? Can represent, for example, the equation 1. But the equation 2 is the same plane. And the equation 3 is the same plane. Okay? So with any point on this plane, boom, 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 a solution. Out the plane, no. But inside the plane, yes. Entonces, how many? My question is how many free variables we have in the problem? Free variable, how many? Remember, the free variable give me information about dimension. So the dimension is 2, the degree of freedom is 2 because we have 2 free variables, right? Entonces yo declaré que y and z, bueno, this is completely independent. You declaré x and y, que es free variable. And you put x as a function of this is non-free variable. This is declaration, definition. Entonces, my solution set is triple order because living in the 3-dimension problem, such that x is equal 10 minus y minus z. So you take, for example, either equation, you take the easier, que es the number 1, and you solve for x, que es non-free variable, as a function of the free. And comma, y and z are any real number. Okay, synonymous to say free variable. Do you understand? So basically, my solution is the plane. What plane? Either plane, because by the way, it's the same plane. It's clear? It's clear or no?
Yes.
Okay, super. Let's move in. Okay, let me show you the interpretation of this. Look. Interpretation is, I put the equation in the software. I see it's the same plane. You don't see very well, but we can delete. You see color. Yeah, I put it yellow color, green color, and red color, and overlap the plane. Okay. Remember, the graph in 3D is not important. Don't frustrate for the graph in 3D. It's not important. Okay, now let's spend the rest of the time we have to see application. What kind of application? Well, the solution for the word problems. I bring 3 word problems. No big deal, easy. The first word problem talking about the mixed problem. So you have in the hospital using 15% bleach solution to disinfect quarantine area. How much 16% bleach solution must be mixed with the 18% bleach solution to make 50 liters of 15 bleach solution? Wow. Okay, I try to do a sketch to understand. But what means in one container we have 15% of solution. This is a bleach solution to clean something, disinfect. Well, that means in the volume of this liquid we have 15% of pure bleach, and the rest, is 85, because total is 100% is water. This is the concentration. So it's a concentration of this. Does it make sense or no? Okay, you put 6%. Okay, it's low concentration. I need 15. I need 15 because 15 is proof that the bacteria virus is killed with the 15%. The 16 is not enough, but 18 is too much. So you put together, make sense that the concentration is the intermediate value, is 15. Suppose que no 15 is 30%. It's impossible to create this solution because we have available 6 and 18. And when you mix together, you expect one concentration gets intermediate in between 6 and 18. No? So 30% is impossible. But 15 is yes, it's acceptable in this problem, right? Do you understand the problem? So the first thing you should do is understand the problem, no? When you understand the problem, you will be able to set out the equation for the problem. This is the challenge of the word problem. The word problem is understand the problem, you set out the equation, and after the rest is algebra, and end the story. Okay, now it's moving. Let me try. We have different quantity in that problem. One is concentration. Concentration. Let me call concentration C. And we have volume. And we have 3 different concentrations, 6%. We have 18%. And we have 15%. And volume, but we have 2 kinds of volume. No, we have volume. And volume is, I call X, I call Y, yeah, I call 50, no? Because it's giving the volume that we need. To find the bleach volume, no? In liters. So we are talking about liters. This is volume in liters. concentration es percentage. Es obvio que yo multiply this, pero no en percentage. You multiply en decimal, 0.06, multiply by the total volume, and you get exactly this expression. Give me the information, how much bleach we have in this container. Okay. Likewise, this is 0.18 y, and this is multiplication. This is multiplication 50 times. Put in the calculator 50 times, and decimal 0.15 is 7.5 liter. Okay, in this container, we have 50 liters. We have only, or we need only 7.5 liter also, pero de bleach. Okay, entonces we are ready. We are ready. When you are doing this format, this is important, guys. You see how the tendency of the system of equation is using matrices, because matrix is array of element in this order, right? Down. Okay, entonces it's good. And so far, no, today we are doing like antique mathematicians here. Now, after we are solving using computers. Okay, entonces I saw, wow, look at that. This equation is clear for me. Look, total volume of this container plus this total volume of the second container is equal the volume I need. So x plus y is equal to, because x represents the volume of the container, que is 6%, and the bleach plus bleach is equal to total bleach. I have equation number 1 and equation number 2. End the story. This is my system. I copy separately. Equation 1, 0.06x plus 0.18y is equal to 7.5. Equation 2. And it's my system, and the rest is algebra. Do you understand very well how I set up the equations or no? And depending on the problem, no? And this problem is mixed problem. Basically, the quantity you manipulate in the equation is concentration, volume, and the amount of substance. Maybe it's bleach, maybe alcohol. I don't know, depending on the problem, no? Okay. Do you see or no? Come on, guys. Yes or no? Answer me. Are you sleeping or no?
Yes.
Okay. Entonces, what do you recommend me to do? By substitution or elimination?
We can do substitution.
Why? I need to understand why. Because you take advantage what fact?
Isolate variables.
Because coefficient is 1 or negative 1. Yeah. You isolate specifically to answer the question, how much 6? So I need to find the question. Well, you solve both, but the question is X. Because I need to discover how much 6% bleach solution must be mixed with the, okay, so it's X. So you solve for Y, get the opposite variable. F50 minus X. And substitution here. In the Y place. In another equation. So far we have 0.06 X plus 0.18 parenthesis 50 minus X equals 75. Okay, you apply distributive property and you multiply 0.18 times 50. The answer is 9. That's 0.06x plus 9 minus 0.18x equal 75. Okay, let me see, I'm checking 0.18 is 0.18, yeah. Sorry, this is 7.5, no? I make a mistake, no 75. 7.5, look at that. liter. Okay, good. Now combine later. Well, no. I combine this guy and this guy together. Why not? Just 0.18 minus 0.09. So because negative 0.9. A negative 0.09 x. No. A ver, no, está inglés. Es 0.18, es 12, ¿no? Minus 0.06. Es 0.12. Es 0.12. Of course, negative, ¿no? Negative 0.12 x. In the right hand side, I have 7.5 minus 9. Okay, 7.5 minus 9 is negative 1.5. Negative 1.5. Finally, divide both sides by negative 0.12. Okay, and negative divided by negative positive. And the answer is 12.5. X is equal 12.5. Liters of the solution, 6%. Is the answer for that problem. To verify everything is okay or no, let's compute it. Why not? The y value. But this is out the question, no? To solve that, I recommend using the easier equation. It's obvious it's the number one equation. No? So y is equal 50 minus 12.5. Okay, it's 50 minus 12.5 is 37.5 liters. So the mixture is composed by 12.5. So x is equal to 12.5 is x liters, and y 37.5 liters, and together 50, no? For sure. And let me verify to double check it. No, not necessarily do that. See the concentration is 15% or no. So I go to the formula for the concentration, the bleach concentration. I plug it in. I plug in 0.06 multiplication by 12.5. This equation plus 0.18 multiplication by 37.5, and should be, I don't know if it's true or not, 7.5 liter of bleach. 12.5 multiplication by 0.06. The answer is 0.75. Wow, too small. Plus 0.18 times 37.5. The answer is 6.75 again. And this together is 7.5. Super. This is double checking. And this is complementary answer. The answer that they want is this answer. Do you understand very well this problem?
Yes.
Okay. Listen to me. I understand very well. The word problem is always a challenge, because you need to understand the word problem. You need to be able, using your common sense and imagination. They are not recipe. The equation can satisfy this problem. And the rest, the important thing for me now, is the algebra. Okay, the algebra behind that. Okay, using substitution, indicate what's easy by substitution or elimination. We have time to do one or another problem. Yes, we have time. We have time to do another problem. What problem? This problem is easy. This problem is easy. Okay, let me erase. I need to erase. Erase that part. Erase. Oof. Wow, what's going on? Wow. Okay. Okay, my whiteboard is frozen. Ow. Ouch. Okay, there you go. Let me delete that part. Let me delete also. Okay, let me move this slider. No, this slider is impossible. Delete. Okay, the whiteboard frozen. That's mean. I can interpretation que the whiteboard don't want to do the next word problem. Now let me see if it's working or doesn't work. No. Okay. Okay, guys, entonces we stop because the whiteboard don't want que I continue. Let me delete that. Wow, delete everything. Delete everything. Okay, too much for one day. So now, next time we continue applications of the linear system of equations. Okay, we have a lot of applications to study. Okay, remember today, everyone submit the test online, Alex, and send me by email the reading test. Correct? Clear? Clear?
Yes.
Clear?
Yes.
Okay. Bye-bye.
Bye, Professor.